So last week we talked about significant figures, and we're going to talk and we're going to delve more into it today. But really, you have to know, how do you count the number of significant figures in a number? And remember, leading zeros, okay, we don't count leading zeros. Trailing zeros, we do count, all right, only if there's a decimal point, all right? Okay, so those are the two big ones, okay? Trailing zeros, we count only if there's a decimal in our number. All right, some numbers, okay, well, let me go to this first. Quantities that are measured, all right, so mass, volume, pressure, force, any of those that are measured, we are going to use significant figures to determine how precise those numbers are, okay? Some numbers, okay, and this is one of the hard parts. Some numbers are exact numbers, and when a number is an exact number, then what we say is it has infinite significant figures, okay? So something like this: 1 minute is exactly 60 seconds. That's definition, okay? So this 1 minute is exactly 60 seconds, okay? So this 1 minute right here has infinite, and the symbol for infinity is like a sideways 8, okay? So infinite sig figs, all right? And the 60 seconds has infinite sig figs, because those are exact numbers. Now I'm going to go over some in just a little bit that aren't, okay? So other examples that have infinite significant figures. 1 day is equal to 24 hours, okay? Both these have infinite significant figures, because 1 hour or 1 day is defined as exactly 24 hours, okay? So both of these would have infinite sig figs. Some others: 1 meter is defined as exactly 100 centimeters. Okay, so this 1 meter has infinite sig figs. And the 100 centimeters has infinite sig figs. Okay, let me get some other ones. 1 mile. 1 mile, by definition, if you look up the Webster definition in the Webster dictionary, 1 mile is exactly 5,280 feet. Okay, so that means this has, in the 1 mile is exact, so that's infinite sig figs. And the 5,280 is that's an exact number, so that's infinite sig figs. Okay, but not all of the conversions we've been using have infinite sig figs, okay? So for example, and some of these conversions, the one is exact, so when one of these is equal to so many of this, right? When we say the one, that's actually exact, okay? It's the other number that's gonna have sig figs, okay? So something like this, we've been using this one, 1 foot, right? So 1 foot is exactly 0.305 meters. So this 1 foot, by definition, that's exactly 1 foot, but this is an approximation because the decimal, it's the precision of it, okay? So we know this 1 foot has infinite sig figs, but this one has, now remember, this is a leading zero, so we don't count it. This one has 1, 2, 3. This has 3 significant figures. And this is going to deal with how we do our conversions. And that's why we were getting some of our conversions wrong last week, okay? Another example of this, I'm looking at my distance time chart. 1 inch is 2.54 centimeters. This 1 inch is exact, but this 2.54 centimeters is an approximation. Let me scoot it up for you. So 1 inch, 2.54 centimeters. 1 inch has an infinite sig figs. 2.54. This has 1, 2, 3, because they're all digits 1 through 9. So we have 3 sig figs on this one. 3 significant figures. Okay. Another one of these is 1 year. And this one is exact, or 1 year is exact. So that has infinite sig figs. And we've been using 365 days, but that's actually an approximation. And an even more precise approximation, but it's still an approximation, is 365.25 days. And this one, all of the digits are significant, so we have 5 significant figures. So 5 sig figs. Okay. Another one is 1 mile is equal to 1.609 kilometers. So this has infinite sig figs because we're saying 1 mile is exactly, and then this is the approximation. So this would have 1, 2, 3, 4. The zero's counting because it's sandwiched in between the 6 and the 9. So this has 4 significant figures. Okay, so some of these numbers, and so we're going to be able to count when it's exact on the conversions. One of the numbers is always has infinite significant figures, and the other one could also have infinite significant figures, or it could have a finite amount of significant figures. All right, let's go to multiplying and adding, and I'm going to go over why we were getting some of our answers wrong last time, okay? So we're going to talk about multiplication and division rules. Okay, so when we were doing these conversion factors, we were multiplying. And what we were doing wrong last week is we weren't following the multiplication and division rules correctly, okay? So anytime we multiply or divide, all right, a problem, and the answer to that multiplication division problem will have the same number of significant figures as the number used in the calculation with the least number of significant figures. So what we were doing last week is we were giving more precision than we actually could give, okay? So what we have to know is how many significant figures. We look at all our numbers that we're multiplying and what's the least number of significant figures, okay? So let's do this first conversion. So 4.2 years, 4.2 years. So we're gonna start with that and we're gonna convert that to seconds. So 4.2 years. Okay, and then we're going to start our conversion process. So times, okay, and then we know from conversion, from our conversion tables, we know that 1 year is 365.25 days. Okay, and I'm going to talk about significant figures in just a little bit, okay? So now that 1 year is exact, but this is an approximation, okay? And then times, okay? And then now what we have is days, okay? So now we're going to multiply by 1 day is 24 hours. And this has infinite significant figures, and this has infinite significant figures because, all right, this is definition. 1 day is exactly 24 hours. Exact. Both of them are exact. This one's exact. This one's not exact. Okay. And then times. Okay. Now we need to go to minutes, or we could actually go to seconds too, because there's a conversion that I've taught you. And you know what? I did this. I wrote HR for hour, but you could also write H. Okay. When you see H, that means hours, okay? And then 1 hour is 3,600 seconds. Okay, so let's go ahead and get our answer, all right? And so I'm gonna take my calculator, I'm gonna multiply, it'd be this times this times this times this all over 1. So we just really need to multiply 4.2. Let me clear this out. 4.2 times 365.25 times 24 times 3,600. Okay, so we get this number, and we want to record this whole number. So this would be 132,541,920, and this would be seconds. Now, this is too precise. Why? Because when we were doing this, we only had some numbers that we were multiplying that didn't have that many significant figures. Okay, so this one right here, what we started with has 1, 2. This has 2 significant figures. Okay, this has infinite significant figures, but this top one has 1, 2, 3, 4, 5. This one has 5 significant figures. Let me go ahead and write 2 here. So there's 2 on this one, there's 5 on this one. This 1 day has infinite because that's exact. 24 hours is exact. So this one has infinite significant figures. 1 hour is exactly 3,600 seconds. So this one also has infinite sig figs. Okay, so what's the least one? It's this one. So our number can only have 2 significant figures. That's it, okay? So the first significant figure is this 1. The second one is 3. So that means we have to round, and we're gonna look at this third one, which is 2, and that's gonna become 0, and then we need zeros for the rest of the place values, okay? So this is 1, 3, 0, because the 2 is gonna cause this 3 to stay 3, comma, 0, 0, 0, comma, 0, 0, 0 seconds. That's as accurate as we can get for our answer based on we only have 2 significant figures here, okay? So that means, and we could put approximately here. If you put equals, that's okay. In scientific notation, all right, it'd be 1.3 times 10 to the, and we know it's gonna be a positive power because this is a big number. So 1, 2, 3, 4, 5, 6, 7, 8. So 1.3 times 10 to the 8th seconds. Okay, so we could report it as the number, or we could report it in scientific notation. And remember, when we write it in scientific notation, we can tell that there's only 2 significant figures. Why was there only 2 significant figures again? It goes back to this. When we multiply and divide, and that's what this was, a multiplication division problem, we are only as accurate, our answer can be only as accurate as the least number of significant figures. And this was the least number of significant figures, and that's why our answer only has 2 significant figures, okay? So our answer only has 2 significant figures. All right, let's do another one like this. So our next problem here is one we did last week, okay? So it's, again, how many picoseconds are there in 7.10? And that H right here represents hours. And a lot of us weren't realizing that, okay? All right, so I'm starting with hours, okay? And this has 3 significant figures involved in it, okay? So I want to convert to picoseconds, but before I can convert to picoseconds, I need to get hours to seconds. Okay, so I need to know how many picoseconds. So we know 1 pico of something is equal 10 to the negative 12th of something. So the something here is seconds. So 1 picosecond, okay, is equal to 10 to the negative 12th seconds. Okay, and this is included. I included this chart for your homework tonight. Okay, so we know 1 picosecond is equivalent to 10 to the negative 12 seconds. All right, so here we go. We're going to start with the hours. So 7.10 hours. We're going to multiply to get seconds. And from the conversion sheet that I provided in Google Classroom, this means 1 hour is 3,600 seconds. So now I have the number of seconds, And then I need to convert to picoseconds. Well, I know 10 to the negative 12 seconds. The other day I was doing 1 times 10 to the negative 12, but you can do 10, just 10 to the negative 12. So 10 to the negative 12 seconds is equivalent to 1 picosecond, and I want those on top. So my hours here cancel, my hours here cancel, my seconds here cancel, my seconds here cancel. Okay, so I'm going to keep this as 1 over 10 to the negative 12, and I'm going to multiply the 7.10 times 3600, because any 10 to a power I want to keep by itself, okay? That's just helpful in writing our final answer, okay? So 7.10, I'm just grabbing a calculator, 7.10 times 3600, and that is 25,560. So this is 25,560 times 1 over 10 to the negative 12 picoseconds. Okay, now mathematically 1 over 10 to the negative 12, there's an exponent rule that says if you have 1 over some base x raised to a negative exponent, that's always equivalent to that same base of x raised to the positive exponent. So this right here could be rewritten as 10 to the 12th. So this is 25,560 times, and again, this could be rewritten as 10 to the 12th picoseconds. Okay, so now what is this answer? Okay, so this isn't in scientific notation yet. Okay, so there's a decimal here, so 1, 2, 3, 4. I can rewrite this as 2.5560 times 10 to the 4th power, because I know that's a big number, a number bigger than 10, so I know this exponent needs to be positive. And the number of places I moved it is 1, 2, 3, 4, and then times 10 to the 12th picoseconds. So this is 2.5560 times 10 to the 16th, because we add the exponents there, picoseconds. Now this is a wrong answer, okay, because we got to go to sig figs, okay? So this number right here has 3, 1, 2, 3. Now, why do we count the 0 here? This is a trailing 0, right? It's a trailing 0, and we have a decimal in our number. So that means this has 3 significant figures, because we're going to count that 0. This 1 hour is exact. The 3600 is also exact. So this one right here has infinite sig figs. 1 picosecond is also defined as 10 to the negative 12 seconds. So that's also infinite sig figs. Okay, so that means our answer can only be the least number, because all of this is multiplication and division. This answer right here can only be as accurate as 3 significant figures. So we can only use 3 significant figures. So that means here's our first significant figure, here's our second significant figure, here's our third significant figure. To write this with 3 significant figures, I'm going to need to round, and I look at the fourth one, that's a 6, which is going to cause this 5 to become 6. So this becomes 2.56 times 10 to the 16th picoseconds, and that would be your answer. And that would be correct. That would be the correct answer. And also with the units, it's the correct units, and also the correct number of significant figures. Okay, so you got to think of all this. You got to think of units, significant figures, and then the actual, process of getting your answer. Okay. All right, let's do one more. So the next one I want to do is this one. The speed limit on Rose Avenue is 40 point, and that decimal is going to be important here, okay? Miles per hour. What is the speed limit in meters per second? Okay, so we have 40 point, and that's miles in 1 hour. So that's miles over 1 hour. Now that point right there tells me that I count this trailing 0 because there's a decimal place. So this has 2 significant figures, involved in it, okay? So this has two significant figures. This 1 hour is exact, okay? So then times, all right? Now we want to convert to seconds because we want to get to meters per second. So I know 1 hour is the same as 3,600 seconds. So I now have miles per second, but I need to get to meters, right? And I know that 1 mile is equivalent to 1.609 kilometers. Okay, so now I have kilometers per second, but I need to get to meters per second. And now I know that I have 1 kilometer is equivalent to 100 meters. Okay, so this would be 40 times, I don't need the one, so 1.609 times 100 over, and I would just put 3,600 because I don't need the ones. And that would be meters over seconds. Okay, so I'm going to do this on my calculator. So clear, and then do 40 times 1.609 times 100, and then divide by 3,600. And I get this long decimal, right? So I'm going to write the whole thing, 1.78, and then 7777. I have 1, 2, 3, 4, 5, 6 sevens. And then followed by an 8 meters per second. Okay, so we want to write all the decimals and we want to carry all the decimals into the calculation, but then we want to talk about, okay, so what's the accuracy or precision of this, okay? So this number right here has two significant figures because this one has infinite and this one has 2. So this has 2 significant figures. This 1 hour is exactly 3,600. So this would be infinite significant figures. 1.609 has 4 significant figures and 1 mile is infinite. So this would have 4 significant figures. 100 meters, 1 kilometer, each of those are exact. Those are exact. So that'd be infinite significant figures. So the least one is this one, right? 2. So we can only go to 2 significant figures. So this 1.78 blah, 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 right? We can only actually use the first 2. So this 8, because that's the third significant figure, we're going to use the third significant figure to round to 2 significant figures. So this becomes 1.8 meters per second. So 40 miles per hour on Rose Avenue is 1.8 meters per second. And that's as accurate and as precise as we can get it because of the limitations of the measurements that we were using up here. Okay, and we can only be as good as the least one, okay, as the least number of significant figures. Okay, let's talk about adding and subtracting next. All right, so when we add and subtract, the rule is a little bit different, okay? We can only be as precise as the least precise number. Now, notice it doesn't say significant figures. You really don't even need significant figures when you add and subtract, okay? It's the least precise. So the one that has the least number of decimal places is the one we have to use, okay? So like, let's do this first one. Find the sum, which means add the following distances. So 3.21 meters, 43.2 centimeters, and 35.8 meters. Now there's a problem with these. The only way we can add these is if they're all the same units. We don't have the same units, so we have to start paying attention to units more than what we have been, okay? This is meters, this is centimeters, this is meters. What I would do, you have 2 options, but the easiest way is let's just switch this one to meters, okay? The other option is to switch both of these to centimeters and then give our answer in centimeters. I mean, both are right. It's just you got to realize this is probably less work if we only have to switch one of them, okay? So we got to do a conversion. So this is 43.2 centimeters okay? And that has 3 significant figures, right? And we're going to multiply that by, we know that 100 centimeters is the same as 1 meter, okay? And so our centimeters cancel, we're going to be left with meters, and this turns out to be 0.432 centimeters. Now, this has infinite number of significant figures. This one has 3, and we're actually reporting our answer as 3 significant figures here too, okay? All right, oops, you know what? I accidentally put centimeters, but it's actually meters, huh? Let me erase that. Okay, so this should be meters. Okay, so now the sum of the following distances, now we can add them, right? So we have 3.21 meters. We're going to add to that this one, which is 0.432 meters. And then we're going to add to that 35.8 meters. Okay, so we go to add these. You can use a calculator if you want to. 3.21 plus 0.432 plus 35.8. And that gives us 39.442 meters. Okay, I'm just double checking to make sure I typed everything in right. Yeah. Okay. Now, we want to report this answer, but now we want to give the answer to the correct number of significant figures, okay? So if you look at this, okay, how precise is this? Well, this is very precise. It's 2 decimal places, right? This is even more precise because it's 3 decimal places. And this one right here has only 1 decimal place, right? The tenths, all right? So this is the hundredths, this is the thousandths place, and this is the tenths place. This is our least precise because it only has 1 decimal place. Okay, so that means our answer can only be as precise as this one. This answer can only go to 1 decimal place. So these 2 decimal places need to go away. Well, what are we going to do? Okay, so we're only going to report an answer of 39.4, and we're going to round this 4, and we're going to look at this next digit right here, this 4, to determine whether we should round this up or not. So this 4, because it's 4 and it's not 5 or larger, then we're going to keep it 39.4. So our correct answer to this is 39.4 meters. And that's accurate to, or I shouldn't say accurate, that's precise. That's as precise as we can report our answer, because these are measured values, and this is our least precise measured value right there. Okay, so that's when we add or subtract, it's you report your answer with the same precision as the least precise one, which would be this one right here. Okay, that's it for that one. So for this final problem, okay, I'm giving you the length and width of a rectangle, and they're measured to be 117.2 centimeters and 9.28 centimeters. And I want to calculate to the correct significant figures the area and perimeter of this rectangle. So this is really kind of a math problem, but we want to do it correctly for science class, okay? So a rectangle has 4 sides, right? And 4 right angles, and the 2 shorter sides are called the width, and the 2 longer sides that are opposite one another are called the lengths. So I would label this one 9.28 centimeters, and I would call that one my width. And then this one is 117.2, and that would be my length. I would call that one length, all right? And we should know that the area formula is length times width. Okay, so that would mean our length is 117.2, and our width is 9.28. Okay, and then that would give me, I'm going to put that in my calculator. I'm going to give you the entire answer the calculator gives me, and you should do that. 117.2 times 9.28, and we get 1087 0.616, and this would be centimeters squared. But how do we report our answer? So we're not done yet because we haven't reported our answer, okay? How many significant figures does this one have? Well, 1, 2, 3, 4. This has 4 significant figures. This one has 1, 2, 3 significant figures. Remember, when we multiply, we can only give our answer to the least number of significant figures. So in this case, we can only report this to 3 significant figures, okay? So what does that mean for this, okay? So 1, 0, 8, right? 1 is significant. The 0 because the sandwich is significant. 8 is significant, okay? All right, so then that would be our 3 significant figures. So to round this, we need to look at the 4th significant figure, which is a 7, which is going to cause this to be a 9, okay? So the correct rounding of this would be 1090 centimeters square, or square centimeters. And that would be the correct answer to the correct number of significant figures. So we could also write this in scientific notation, all right? And the decimal place is right here, that's not being written. And so so it's 1, 2, 3. So this is 1.09, because that would be 3 significant figures, times 10 to the, and this is a number bigger than 10, so the exponent needs to be positive. So 1, 2, 3. So 1.09 times 10 to the third centimeter squared. Either one, okay? If you type your answer as this one, or you type your answer as this one, you're going to get it right, okay? All right, and to type in centimeters squared, we're going to have to use that caret key, and we're going to have to type something like that, okay? Because you have to write the correct units too. All right, so let's next do the perimeter. Okay, so recall, perimeter is the distance around. Okay, so we have 2 links up here. Let me slide down. We have 2 of these links and 2 of these widths, right? So the perimeter is just really just 2 links plus 2 widths, okay? So that'd be 2 times 117.2, and that'd be centimeters, plus 2 times 9.28 centimeters. This 2 is not a measured value, so it has infinite significant figures. And so this answer right here is going to be, it's going to have the same number of significant figures as this number right here because it's multiplication. Okay, so 117.2 times 2 gives us 234.4. And then plus, and 2 times 9.28. And that's 18.56 centimeters. Okay, now recall, this one's the least precise, right? Because it only goes 1 decimal place. This one goes 2. So this is the least precise. That means our answer can only have 1 decimal place. Okay, so take the 234.4 and add 18.56. And you get 252.96. Centimeters, but that's incorrect for the precision of this number, okay? So remember, we can only go 1 decimal place, so this 6 is actually going to cause this 9 to become a 10, because if we go up, and then because this becomes a 10, we got to carry the 1 over here to this 2. So this answer actually becomes 253 point, and we would need the point 0 centimeters, because we're only precise to 1 decimal place because this is the least precise, okay? All right, so I just wanted to go over some examples with you on the multiplication and division rules. You should also realize that squaring a number is actually multiplying. So 5.32 squared really means 5.32 times 5.32. So when we go to multiply these, our answer can only be as precise as 3 significant figures, okay? Because squaring actually means multiplication, okay? So exponents mean multiplication. And so the least precise of these, they have both the same precision, but it's only 3, okay? All right, that's gonna happen tonight. You're gonna have to take a square and go, oh wait, it's just gonna be the same number. Our answer is gonna have the same number as our base here, okay? Same number of significant figures. All right, guys, that is it.